three things that we do want to get through on this lovely day. Number one is that we wanted to spend a little bit of time working at some word problems and how to apply algebraic thought. Number two, we want to look at situations when there are no solutions and something called identity. And lastly, we have a bunch of letters and we need to get one of the letters by themselves. We call that solve for. So in this case, we're going to solve for W. In this case, we're going to solve for Y. So let's take a gander at the very first one. So two brothers are saving money to buy tickets to the concert or a concert. Their combined savings is $55 and one brother has 15 more than the other. How much has each saved? Before we attack, what kinds of numbers do we expect to get out of this? Okay, so we do expect to get some money that's going to be under 55, and let's see what we have. So we have two brothers, and it doesn't matter what you call them, brother A, brother B, or something like that, B1 or B2, it doesn't really matter. But notice here that if I have A is brother 1, and B is brother 2. Now, some of you can jump already to equations. Totally fine. Some of you can jump all the way to answers. Totally fine. What we want to be able to do is take a more simple situation and be able to apply the thought process so when it does get more complicated, you can use rules like this. Okay, now we also know that one brother has $15 more than the other, and we know that together their combined savings is 55. So what operation is combined? Is it add, subtract, multiply, or divide? Everybody? Add. Good. So we're going to add two things together. So I know that A plus B is 55. I also know that one of them has more money than the other. We don't know which is which, and it doesn't actually matter. So I know that A, and I'm just going to call it A, has $15 more than B. So now what I'm going to do is take this guy right here and substitute it in for there. So now the equation I can work with looks like this. B plus 15, so that's what one brother has, plus what the other brother has, just B, is going to be 55. Now we see we can combine my like terms. I have a one B here and another B there, so I get 2B plus 15 equals 55. Now I'm going to subtract 15 from both sides to get 2B equals 40. So B is $20. Now we're not done. We didn't quite answer it because it does ask me the question, how much has each saved? How much has each saved? So that means brother 1 has $20 brother 2 has $20, and this one has got to have $15 more, $35. And there we go. How did I get that second one? Remember over here, I have A is equal to B plus 15, so I put the B there.
Your lightsaber.
Tis. So my final answer over here is that brother 1 has $35, brother 2 has $20. It doesn't actually matter which one you call brother 1, brother 2, as long as you're being consistent. Originally I called A brother 1, so that's what I just want to be consistent there. And this one was brother 2. Look at this practice here. Consecutive means in counting order is one way to talk about it. And we have 3 of them. And since we have 3 of them, just to set it up, if I have one number that is x, how do I get to the next number? What do I add to x to get to the next number? I'm going to say my next number is x plus 1. And how do I get to the next number after that? So it's going to be x plus 1 or x plus 2. So this is how we can write consecutive numbers. This is my, pretend I'm just saying my 5. 5 plus 1 is 6. 5 plus 2 is 7. So 5, 6, 7 as an example. And of course, we do know how much it's worth. It says it all adds up to 126. Now, sometimes in life, things just don't work, okay? Sometimes in life, things just don't work. Or they work always, which in some ways is saying everybody's special, so no one is. Okay, remember the point of a solution. A solution is to find the unknown. Is to find the value of something you don't know. I already know how big 1 is. It's 1. I already know how big 5 is. It's 5. But what I don't know is what the x's value is. So sometimes we can find it like we did in the previous example. Oh, look, I found that one brother has $20. That's the one thing I didn't know. Sometimes you get a situation where no new information comes up. So let's walk through this one here. So I'm going to attack this in however way you would like. There's more than one way to approach it. But just for simplicity, I'm going to distribute the coefficient to both into both parentheses. So 6x plus 6 equals 10 plus 6x. Now what do you know is the same on both sides? The 6x. So when I subtract 6x from the left side, I have to do it on the right side, and they both drop out entirely. And I'm left with a statement that is discombobulating. 6 equals 10, really? When did that start happening?
Wait, how'd you get 6? Wouldn't it be 7?
6 equals 10 is a false statement. Because it tells me a lie, what I now know is that there is no number that I could ever plug in that would make this true. So the actual answer is no solution. And let me learn to spell. No solution. The answer isn't false. The answer isn't 6 equals 10. The answer is no solution. So what I have to do is interpret the algebra. 6 equals 10, I interpret it as false, and so I interpret the false as no solution. So that's what you box or circle, the no solution. So as you walk through this one, I'm going to distribute to get 3y plus 9 plus 5y equals 8y plus 4 plus 5. Continuing on, I get 8y plus 9 on the left side, and that's a 9. And 8y plus 9, so that's a 4 right there, plus 9 there. Now there's a couple different ways to approach this. You can start reducing just the variables. You can take out the the constants there as well. Most likely, most of you probably did something like this. You started sending the variables over, and we ended up with 9 equals 9. But you could have canceled out the 9's too to get 0 equals 0. The point is that this is a true statement, but unhelpful. I already know 9 is 9. That's not the point of this. The point of this is for me to find out what y is, the unknown. So this conclusion, and by the way, these 3 dots right here mean therefore. Therefore, infinitely many solutions. Infinitely many solutions. Every single number on the planet would work. All right, so the very last thing we want to do is to be able to get a variable by itself. Notice here that A is already solved for, meaning A is already by itself. Now, this asks me to get W by itself, solve for W, because sometimes when we have formulas, we don't want to solve for the area, we want to solve for the width or something like that. So how do I do this? I need to get W by itself. So notice I have a W here and a W here. So I'll get to that in a second. But I do want to get rid of this plus LH first. So how do you get rid of a plus LH? What's the inverse of plus LH? It's minus LH. So watch out, my L there kind of looks like a 1, so I have to beware of that. So I'm going to subtract LH over here. Now I bring down the A, bring down the minus, bring down the L, bring down the H. A minus LH. And over on this right side, I have LW plus WH. Now, before I go on, I have to get rid of two things. I have to get rid of this L and this H. If I were to subtract the WH, I now have W on this side. But I'm trying to get W by itself. So notice that W is shared in both of these. So I can take this W and undistribute it. We call it factor. We can factor it. You're not always going to do that. I'm just saying that when it's shared into two terms, you probably would. So I'm going to bring down the left side to be exactly the same, and I'm going to change my L to look like that, just so it looks less like a 1. Now I put the W outside, parentheses, and I say L plus H. So I factored it, that is, I undistributed the W. Now I can divide both sides by the L plus H. Divide both sides by the L plus H. Now, my final answer is this. It's not very pretty, but W is equal to A minus LH all over L plus H. So as we see, it's not very pretty, but it works. Now let's take a gander at the next problem over here. We need to get y by itself. This one is already in terms of g. G has already been solved for. So I am going to do inverse. I'm going to unpack everything around the y. So first I'm going to multiply this side by 9 over 4 and repeat the process over here. Now I can bring down the y plus the 3, no longer needing parentheses, and the 9 and the g are in the numerator, all over 4. Now I have to subtract 3 and subtract 3. Now that's not a very clean situation here, so there are a couple different ways to leave the answer. If somebody left it like this, 9/4 g minus 3, that's one way to leave it. This kind of looks like slope-intercept form, right? Y equals mx plus b. So this would be a sufficient, and it's probably the most clean way of leaving it. However, if you wanted to put it as a single fraction, you could have done something like this, where I take the negative 3 and convert that to negative 12 over 4. Why? So I have common denominators there. So then I could have written the answer something like this. Y equals 9g minus 12 all over 4. Something like that as well. However, just to give you the heads up, this is probably the most simple way to leave it.